Hey guys, I wanted to talk to you today about inverse of a quadratic function. So if you are not aware, there's a intro to inverses for a linear function. You might want to watch that first if you haven't watched any of the inverse function videos. So this is the next step. This would be the inverse of a quadratic function. And if any of this is going too fast while you're taking notes, feel free to pause and then press play whenever you're caught up on your notes. We're going to start with one of my favorite functions, really simple basic parabola centered at 0, 0, going up. So very basic quadratic function right there. And in fact, if we look at the original points on this parabola, pretty predictable, right? If you plug in, for example, a -1, you get out a +1, etc. So one of the things that we did in the last video was when we talked about taking an inverse always takes every x, y and switches it. And so we took all of the x, y's and we switched their places, and then we graphed the new function. So and you can see that when I graph 0, 0, 1, 1, 1, -1, 4, 2, 4, -2, I get sideways parabola. So notice the parabola that initially opened up and the y values were increasing. Now we get a sideways parabola and it opens to the side, but it opens to the side where the x values are increasing, all right? And that is because every inverse is a flip on that y equals x line, and we did it in the last video as well. So if you held on to that line, y equals x, and you took the original parabola that opened up and you flipped it, you get a sideways parabola going to the right. So that's something that's really nice and helps us with graphing. Unfortunately, that new inverse is not a function, and often when we take an inverse, we like that inverse to be an inverse function. So it's okay, it's not a function, but if I asked you what is the inverse function, you wouldn't be able to give me the inverse function because that sideways parabola is not a function. So oftentimes we run into that problem. And so let's look algebraically at what happened. So we're going to switch the x and y's to the original function, and we're going to call it x equals y squared. So that's my parabola that goes to the side. And then if we wanted to, for example, solve for y, we would take the square root on both sides, again, plus or minus square root of x equals y. And now we see that we have really two equations here. We have the equation y equals the square root of x and y equals the negative square root of x. So that's really interesting. So when you're seeing this sideways parabola and you look at it, you can really look at it as two pieces. The top, which is the square root of x, and the bottom piece, which is negative square root of x. So there's that top piece, and there's that negative piece. And if you put them together, then you get not the function. You get not the function x equals y squared. So you can think of it as two separate functions or together one relation. Okay, so those are functions, but above, not a function. So let's talk about what we'd have to do. And so if we wanted to take the inverse of a function, and we know we want a function, you might have to restrict the domain of the original function. So that's what we're going to do. We're going to not draw the whole parabola. We're going to restrict its domain so that when we flip it, we'll actually get a function. And so I'm going to start with a parabola, but I'm only going to graph the right side of the parabola. So that x greater than or equal to 0, that's what I call restricting the domain. I'm only graphing the right side of that parabola. So if I were to graph the whole parabola, it would look like this. And then if I flipped that parabola on the y equals x, I would only get the top piece of that. And so now I get the function y equals this positive square root of x. And so from the original function, I actually get an inverse function. And if I were to restrict the parabola and only do the left side of the parabola, then you guessed it, I would get only the bottom side of that function, that inverse function, which is y equals negative square root of x. So that's one way around the fact that if I flip the whole parabola, I wouldn't get a function, is to not flip the whole one, just flip half of the parabola, restricting the domain. And that works for pretty much anything where you know you're not going to get a inverse function. So for example, if you look at the absolute value function, for example, I have here, and I flipped it, I would get a sideways absolute value graph, which isn't a function. So what should I do? I should probably restrict that domain. And if I restricted it, then that first piece would give me the second piece, which would be a function. And every single point could be just switched and I would get a function like that. So one big idea that comes out of this is that if we look at the domain of the original function and the range of the original function, then that domain and range also switches. And that's an easy way for me to know which piece of the graph I'm going to get. So for example, if I look at the domain and range of the original function where I only graph the right side of the parabola, that domain and range, that x greater than y, x greater than or equal to 0 and y greater than or equal to 0, that will switch and I'll get x greater than or equal to 0 and y greater than or equal to 0 in the square root function. And if I look at it in the left side of the parabola, a little bit better to see, notice the x and y's also trade places. And so whereas I had x less than or equal to 0, now I have y less than or equal to 0. And so those guys switch places as well. So interesting idea with the domain and range. Hopefully that helps. And I'll give you a couple more ideas about taking an inverse function. I think the next one that we're going to do is we're going to take the inverse of an exponential. Okay, so keep on doing your math, and excellent job, people.